Moving on to 4.2, application of equations. Now these are going to be a little tough now because we're looking more at word problems. And when we use word problems, we have to be able to read words and then take the verbal expression and convert it to a mathematical expression. Now, that can be pretty challenging sometimes depending on the circumstance. But so you can see that there's a number of verbal expressions when you might say something like 5 plus a number. But when you don't know the number, then that's going to be the unknown variable. So you can replace that with a variable, whether it's n, p, q, r, whatever. In this case, it's represented by x. So if you want to write this out in a mathematical expression, it would be 5 plus x. Add 20 to a number. Well, you're going to start with the unknown variable as x, and we're going to add plus 20. So the sum of a number and 12 is x plus 12. 6 more than a number, well, we'll start off with the number and then we'll add 6 to it. These are the mathematical expressions for this verbal expression. Here are more examples. 3 less a number, that's p minus 3. A number decreased by 14, p minus 14. By the way, p, that could be x again, it could be n, it could be anything. It's just an unknown variable representation with using any kind of alphabetical number. And then 10 fewer than p would be the p minus 10. So if you can remember how these verbal expressions can translate into a mathematical expression, that can be very helpful for you. In example number 3, the product of a number and 3 would simply be 3y, or y just being any variable. 4 times a number is 4y. 2/3 of a number, 2/3 y. A number divided by 2 would be y divided by 2. The sum of 3 and a number is multiplied by 5. So the sum of 3 and a number, that's within the parentheses, 3 plus y. The sum of 3 and a number, 3 plus y, is multiplied by 5. So you need to put in the parentheses there to make sure that you understand the order of operation. You're first adding these numbers together, and then you're multiplying it by whatever the result of that is. You multiply it against the 5. And then finally, 7 is multiplied by the difference of an unknown number and 14. 7 is multiplied by the difference of an unknown number and 14. So the unknown number minus 14, again, in parentheses, making sure we resolve that first. And whatever that result is, we're going to multiply by 7. Moving on to example number 4. Translate the product of 5 and a number decreased by 8 is 100. So this is an entire equation. It's not just an expression. We're adding an we're adding an equal sign to it so that it becomes an equation. So the product of 5 and a number decreased by 8 is 100. So the product of 5 and a number, well, we'll take that into consideration first. The product of 5 and a number, well, and a number decreased by 8. Okay, so this one's a little bit trickier than we would have thought, but a number decreased by 8, a number decreased by 8. So this could have been interpreted a different way, but we'll go with the textbook in this case. A number decreased by 8 is what they're looking to add to resolve first. So a number is y, we're going to open up the parentheses, minus decreased by 8. So we have our parentheses on the outside of these, y minus 8. And then that is going to be multiplied by 5. So we'll put the 5 out, but the 5 is on the outside of the parentheses. And then the it is 10, or I'm sorry, is 100 equals 100. So we take the verbal equation and translate it so that we have 5 times y minus 8 equals 100. or 5y. Really, you could even eliminate the dot here. So when we're using distributive property, we're going to take the 5 and the y. So 5y minus, the minus sign carries down, 5 times 8 is 40. So 5y minus 40 equals 100. Continuing to solve, we're going to add 40 to both sides of the equation. That eliminates the negative 40 on the left side, which leaves you with just 5y. And then we add 40 to the right side, that's 140. And then we divide both sides by 5, which means y equals 28. The sum of an unknown and 6 when divided by 15 is equal to 7. So this one's a little easier to follow. The sum of an unknown and 6. The unknown, let's represent that by r. Why r? I don't know. It could be anything. But the sum of an unknown, that's r plus 6, or and 6 plus 6. Put that in parentheses. Divided by 15. Divided by 15. We'll put the divide sign 15. So we make sure the order of operation includes that the r plus 6 is within the parentheses. Divide it by 15 equals 7. So that makes it easy. All right, the division sign makes it a little trickier, but here's what we do know. When we have an r plus 6 divided by 15, well, let me put it on a spreadsheet here so that if I were to write this out myself. So the r plus 6, and then there's the divided sign, but I'm going to use what I would likely use anyway. The divided by sign, 15. And then that equals 7. So I know they're using the divided sign, with the line and the 2 dots over and above. But I'm going to go ahead and just put the divide sign here as if this were a fraction. Okay. So if I wanted to rewrite this out as a fraction, r plus 6, and then we're going to divide that by 15. And that's going to be equal to, 7. So just recognize that this is the same thing as this. And then that may make it easier for us to figure out how to solve this problem. Well, to solve that problem, we're going to multiply both sides by 15. Well, if I want to be technical, it'll be 15 over 1. So I'm going to multiply the left side by 15 over 1. And by doing so, the 15s are going to cancel. So this will be a 1, and this will be a 1. What's left? What's left is r plus 6 equals, well, whatever we do to the left side of the equation, we have to do to the right. So I'm going to go ahead and take this, and I'm going to multiply it by 15 over 1, just like I did on the left side. Well, I guess I'll go ahead and fix this so that it looks a little bit more like a real mathematical. Makes it easier for us to solve. I'll make this 7 over 1, which is the same as 7 over 1. All right, so 1 times 1 is 1, so we know that's going to be. So what this is really saying is 7 times 15, which is 105. 105 over 1, but you know that 105 over 1 is 5. So with r plus 6 equals 105, now we don't need the parentheses anymore, r plus 6. Now we still want to find a way to isolate the r's, so to do that we'll subtract 6 from both sides of the equation, and then r is equal to 99. Very good. Very good. Okay, so there are the steps here highlighted for you to solve application problems. What you need to do is read the problem carefully. A sketch may help. So sometimes by drawing things out, just to kind of see where things are at, it makes it helpful for you to try to solve the problem. Identify the unknown and choose a variable to represent it. If possible, write any other unknowns in terms of the same variable. Translate the problem into an equation, solve the equation, answer the question asked in the problem, check your solution using the original words of the problem, and be sure your answer is reasonable. Let's take a look. Ben James is studying monthly demand for Chevrolet Impalas in 2 different regions of the country. He has 14,200 new Impalas to ship to the 2 regions, and he decides to ship 3,350 more to the Southwest region than to the Mid-Atlantic Coast region. Find the number to be shipped to the Mid-Atlantic Coast region. Let's take a look at what we know. He has 14,200 new Impalas to ship to 2 regions. So what do we know? The regions, the 2 region names we have is Southeast region. So the Southeast region, and then plus, what is the other one? The Mid-Atlantic Coast. So let's just call that Mid-Atlantic. Equals 14,200. So this is what we know. It's the Southeast, whatever the number is for Southeast, plus whatever the number for Mid-Atlantic, that's going to be equal to 14,200. So the question is, you know, these are 2 unknown variables. I guess we could say Southeast, we said that's S, and Mid-Atlantic is M. So what does it give us? It tells us that in relation to the Mid-Atlantic region, it tells us that he decides to ship 3,350 more to the Southeast region than to the Mid-Atlantic Coast region. So off to the side here, we really have an equation that helps us really take this unknown variable and put it in the same term as M. And how does it do that? Well, it tells us that whatever we ship to the Mid-Atlantic, we're going to put 3,350 more to the Southeast region. So S, the Southeast region, is going to be equal to M plus 3,350. Now we still don't know how many are going to M, to the Mid-Atlantic. We don't know what's going to S, but we do know that the Southeast region is going to be 3,350 more than the Mid-Atlantic. Well, by doing this made it so that I can replace the S with this expression so that I don't have different unknown variables. So in essence, this S now, I'm just replacing the S with M plus 350. That plus the M again is going to give me a total of 14,200. So now we can look to combine like terms. Well, because these are all additions, it'll be relatively easy. Then we could say, well, there's an M here, and then there's an M here. So 2M, M plus M is 2M, plus 350 is equal to 14,200. All right, from here, I'm going to try to isolate the M. So I'm going to subtract 3,350 from both sides. And that's going to leave me with 2M on the left side. And on the right side, 14,200 minus 3,350 is equal to 10,850. And now, take one last step here. Go ahead and divide both sides by 2. That's going to leave us with m is equal to 5,425. So m representing what's going to be shipped to mid-Atlantic is equal to 5,425. 5,425. Now that we have the 5425, we can go in and plug it in. If m equals 5425, that's the mid-Atlantic coast region shipment. And then the southeast region is going to be m plus 3350. So we take the 5425 plus the 3350. That's going to give us 8,775. If we add those two together, we end up with 14,200, which is what we really wanted to begin with. Okay, moving on to example number 7. A mattress for a single bed is on sale for $200, which is 4/5 of its original price. Find the original price. Actually, we've done similar problems earlier when we were looking at base rate. Let's see how it works. The word of implies multiplication. So 4/5 of its original price, we don't know what its original price is. So we'll use the letter P. So $200 is equal to 4/5. 4/5 of is the verbal expression. Mathematical expression is multiplication, so times, and the unknown variable, let's go ahead and represent that as P. So 200 is equal to 4/5 times P. So to solve for this, we need to isolate the P. If we want to eliminate the 4/5, if you recall, to do that, we just multiply it by its reciprocal. So we're going to take 4/5 and multiply it by 5/4. So if I'm taking 4/5 and I'm going to multiply it by 5/4, everything cancels out to 1. 1 times P is P. Whatever we do to the right side of the equation, we have to do to the left side of the equation. So we're going to take the 200 and we're going to multiply it by 5/4. We just convert this to 200 divided by 1, 200 over 1, and then we solve. So the solution to this, 5 times 200, is going to be 1,000/4. And that's going to be equal to P. We've eliminated this. We've got this updated. So 1,000 divided by 4, let's do that. 1,000 divided by 4 is 250. So P. So 250 is equal to P. There it is. Next example, number 8. Lori Zimmerman has $15,000 to invest. She places a portion of the funds in a savings account and $3,000 more than twice the amount in a retirement account. How much is put in the savings account? How much is placed in the retirement? So what do we have? We have a total of $15,000, and we have a savings and retirement account. So the total is $15,000. So let's go ahead and write an equation here. So whatever she puts in a retirement account plus what she puts into a savings account will be equal to $15,000. Well, we have two unknown variables, a retirement amount that we don't know and an S we don't know. So what do we have to do? Similar to what we did in the earlier problem, we have to find a way to be able to understand how one relates to the other. So what did it tell us? She places a portion of the funds in a savings account and $3,000 more than twice this amount into a retirement. The R is equal to 3,000 more than twice whatever she put into the savings. We'll take two times the savings plus, how much was it? $3,000. So R is equal to 2S plus 3,000. Now all we have to do is substitute the R for this. And if we do that, then we have like terms. So we'll put 2S here plus 3,000 plus the S equals 15,000. Well, I want to isolate the S, which means I can go ahead and subtract 3,000 from both sides of the equation. And 3,000 minus 3,000 will give us, we have to put it, and I guess we will, 2S plus S, because we've rid ourselves of this number here. What is that equal to? 15,000 minus 3,000 gives us 12,000. And we can still combine like terms here. 2S plus S will give us 3S. So 3S is equal to 12,000. To isolate the S, we've got to divide it by 3. What does that mean? S equals 4,000. So what was going to be put into the savings account is 4,000. All right, let's confirm. Let's see, I came up with $4,000. They use Z, I use S, all right? They came up with 4,000. And then now you'll plug it into the formula before. So if 4,000 is S, then we could solve for R now, which is the retirement. That's 2S plus 3,000. So 2S, 4,000 times 2 is 8,000 plus 3 is going to give us 11,000. So that's going to be 11,000. 11,000, R will be then 11,000. And then S is 4,000. So R plus S, 4,000 plus 11,000 equals 15. Okay, so I think this is the last one, example 9, is it? The last example for 4.2 is the Eastside Nursery ordered 27 tree seedlings. Some of the seedlings were elm, costing $17 and $17 each. The remainder of the seedlings were maple and they were $11 each. The total cost of the seedlings is $375. Find the number of elms and the number of maples. Okay, so let's draw up an equation that would make some sense here. What do we know? We know that Eastside ordered, let's hold the off on that. We know that some of the seedlings were elms costing $17. So let's use $17. So $17, and we'll call that E. That's the ohms. So 17 times E. We don't know what E is. That's the number of ohms. And then what are we going to do with that? And then we're going to add to that maples. They cost $11 each. So $11 times M gives us a number, which we don't know what that number is yet. So 17E, $17 for every elm, and $11 for every. So if we add these all together, that's going to be equal to $375. That's what we know. Now, in terms of the number of elms and maples, the number of elms plus the number of maples equal 27. So at this point in time, I have to then isolate so that I can combine like terms. I have to isolate one of these. So let's go ahead and isolate. We could do either one, but let's go ahead and isolate the maples and figure out what are the maples equal to. Well, if I isolate the maples are going to be equal to, what are we going to do? I'm going to subtract E from both sides of the equation. So E minus E means all I'm left with is M. So M is going to be equal to, well, whatever I do to this side of the equation, I have to do to the right side of the equation and say, wait a minute, how can I subtract E from 27? But you can't. So in the end, 27 minus E. We found a way to substitute the M using the variable E. How does that work? Well, we'll keep the E here. So 17E remains plus 11 multiplied by 27 minus E, which will be equal to 375. Okay, so we'll take 17E. We're going to add to that. Now in this case here, we have to use distributed property. So we're going to take 11 times 27 to give us 297. And we're going to subtract from that 11E. Remember how we did this. We have distributed property here. 11 times 27 is 297. The minus sign is going to carry down. And then 11 times E is 11E. And all that's going to be equal to 375. From here, we'll go ahead and subtract 297 from both sides. We'll get 17E minus 11E equals 78. We're going to combine these like terms. 17E minus 11E gives us 6E, and that gives us 78. We're going to divide both sides by 6. And what that means is that E is equal to 13. So that 13 represents the number of elm trees that we're going to be selling. Well, if we're going to be selling, going back to the maple trees, since I'm going to be selling 13 elm trees, then M equals 27 minus 13, which means the number of maples equals 14. Okay, so we have the number of elms as 13 and the number of maples is 14. Should we check? Let's check the numbers. Going back here to the original formula we put together. The formula says 17E plus 11M will equal 375. So $17 multiplied by, so 17E, which is times 13, plus 11 times the number of M's. It was $11 each, 11, and that was going to be multiplied by 14. So in this case, 17 times 13 gives us $221 plus 11 times 14, $154. Well, let's see if this works. 221 plus 154, $375. Was that what we're looking for? That's what we were looking for. So that was a long way to get there, but we got there. We're going to be selling 13 elms and 14 maples.